melting point. It generally increases to the top, going up the group, to the right across the period. Why? Because when it goes to the right, there are more unpaired electrons, and if there's more unpaired electrons that go into the electron C, more positive charged ions will attract to it, and this will increase in the strength of metallic bonding. Because there's more interaction between the two, electrostatically interacted, and this is going to increase the melting point. Having a look at this chart here, if we have an element and it has 3 electrons, these 3 electrons are going to want to go into the electron C that is around it and interact with any maybe positives. It gets to a point where if we start adding maybe 2 more, and now all of them are half filled, it's a lot more stable now. So there's no means to get into the electron C, and it's more comfortable staying within the orbital. So if there's less electrons in the electron C to interact, it's going to decrease the melting point. And that's what we see here. A big drop. As we continue to add more electrons, some of them will be going into the C, but eventually as we keep adding more and more as such, it becomes very, very close to getting that last electron here where all of them are fully filled, and it becomes extremely comfortable in this state, does not want to contribute more electrons into electron C at all, and it's going to be in this position. So it's going to be probably down here. Very, very low melting point. If we look at polarizing power, higher the charge, the more polarizing power. For the cation, also, the smaller the radii, more polarizing power. For an anion, we look at polarizability. Higher the charge, more polarizability. But in contrast, for this one, the larger the radii, the more polarizability. So more polarizing power, more polarizability is more covalent. So the opposite will be true for ionic. Has to be less polarizing power and less polarizability. So this is a chart of a trend. Increasing polarizing power is to the top and to the right. Increasing polarizability is to the left and to the bottom. If we look at this example here, MgCl and NaCl, let's compare. Mg compared to Na. Mg is over here, Na is over here. Mg is a little bit more to the right, so it's going to be more polarizing power. Then we have Cl and Cl, that's constant, so that's not going to change. So because Mg has more polarizing power, it is going to be less ionic. It is going to be having a more covalent character. So it's not going to be held together as strong, so the melting point is going to be lower. As you can see, it is lower than the NaCl.